Dear students, greetings to all. In previous video, we have discussed by homolytic cleavage, heterolytic cleavage, what are the reactive intermediates are forming. So, homolytic cleavage generates free radicals as well as heterolytic cleavage generates carbocations and carbanions. Now, here I am going to discuss about the carbocation. Carbocation, the carbon which is carrying the positive charge is called carbocation. The carbon which is carrying the positive charge is called carbocation. So here carbocation, we can see this is the one example for the carbocation. This is called carbocation. And what is the name of this? Name of this is methyl carbocation. Methyl carbocation. So here we know that carbon, what is the electronic configuration in outermost shell? You can write it as a 2s1 2p3. 2s1 2p3. So in this methyl carbocation, three hydrogen bonded with three unpaired electron of carbon to form that sp2 hybridized carbon hydrogen bond. One s orbital, two p orbital is going to give that sp2 hybridized carbon hydrogen compound. Okay, so here and remaining one electron is there, that is going to last by carbon, so that carbon is going to get the positive charge. That means this will be the vacant p orbital. If you see the structure of carbocation, you see that there are three sigma bonds between the carbon and hydrogen. You have okay, and this is the sigma bonds. Okay, and we have one vacant p orbital that will be perpendicular to the plane. That vacant p orbital is perpendicular to the plane, and the structure is trigonal planar shape. That means three hydrogens in same plane, and the bond angle is 120 degree. So in carbocation, so briefly if you want to talk about the carbocation is the trigonal planar structure, sp2 hybridized and bond angle is 120 degree. There is one vacant p orbital is present on the carbon. So here there is a positive charge on the carbon, that means carbon lost electron. So when any atom or molecule which is carrying the positive charge is the electron deficient. Now stability of the carbocations. Stability order of carbocations. See, carbon, here the carbon is carrying the positive charge which is electron deficient. So to compensate the electron deficiency, we need electron donating atoms to the carbon. So when electron donating atom is attached to the carbon gets stabilization, because whatever the required electron for the carbon is given by the electron donating atom. So electron donating groups increases in the carbon in carbocation, stability increases. Stability increases. So we know that alkyl groups are the electron donating groups. Alkyl groups are electron donating groups. So number of alkyl groups increases on the carbon in carbocation, stability also increases. So here 3 alkyl groups are present on the carbocation. So this is called as a tertiary carbocation. This is called as a tertiary carbocation. And second one is that 2 alkyl groups present on the carbocation, so that it is called as a secondary carbocation. And third one is that 1 alkyl group present on the carbocation, so it is called as a primary carbocation. And finally methyl carbocation. So here the number of electron donating groups increases on the carbon, stability increases. Why? What is the reason? Already I told that because carbocation which requires electron, so number of donating groups increases, stability increases. So tertiary carbocation is more stable than the secondary carbocation. Secondary carbocation is more stable than the primary carbocation. Primary carbocation is more stable than the methyl carbocation. Okay, now how to generate the carbocation? How to carbocation? Carbocation can be generated through heterolytic cleavage if different electronegative atoms are attached to the carbon. For example, carbon which is attached to chlorine, we know that chlorine is more electronegative than the carbon. The 2 electrons in the covalent bond can shift to the chlorine, can move to the chlorine because of the, as it has a more electronegativity than the carbon. So what is mean by electronegativity? Electronegativity is nothing but tendency to pull the electrons towards it. So chlorine having more tendency to pull the electron, so electrons are shifting towards the chlorine and carbon is going to lose the electron. So you are going to get here carbocation plus Cl minus. Okay, so this will be even for the tertiary carbocation also. It is possible. So Br, you are going to get that plus Br minus. Okay, so this is brief introduction about the reactive intermediates, and in this we also can extend in some application type in carbocations that we will see in the next video. So till that, wait for the next video. And